In this video, I'm going to show you the Excel skills for section 9.2 in your book, which is creating a regression line and then using that equation to make predictions. So this is the same problem we were working on back in 9.1. It says in an area of the Midwest, records were kept on the relationship between the rainfall in inches and the yield of wheat in bushels per acre. We want to find the equation of the regression line for the given data and make a prediction row. And then we want to make a prediction to see what is the wheat yield if there are 14 inches of rain in a year. Alright, so starting off, we need our scatter plot. And go back to the 9.1 video if you need to see how we create a scatter plot again. But once you have a scatter plot, you right-click on one of the data points and then go down to Add Trend Line. So right-click, Add Trend Line. And then we want to pick Linear, and then just check the box that says Display Equation. I know in a lot of other math classes, you pick the Display R-squared box also. Well, the R-squared value is the coefficient of determination, which is a different value than R, which is our correlation coefficient that we used back in 9.1. In this class, we do not use R-squared ever, so you do not need to check that box. It is not relevant for this course. So again, I'm picking linear and then display equation, and so that gives us our regression equation. It says that our slope is 4.379, so that's saying for every inch of rain, there is an additional 4.379 bushels per acre of wheat. And then the slope is 4.2668, which would mean if there was 0 inches of rain, there would be 4.2668 bushels per acre of wheat, which seems a little odd to not have, or to have wheat without any rain, but I guess there's some moisture already in the soil. Alright, so once we have our regression line, I want to make a prediction row. So what we're going to do for this prediction row is we're going to plug in our x value into the equation to see how close does the equation match up with our data point that was y. So I'm going to hit equals, then 4.3791 times, I'm going to cell reference my x value of 10.5 plus 4.2668. So according to the equation, if there were 10.5 inches of rain, we would have 50.2474 bushels per acre of wheat, which is close to the actual value of 50.5. It's a little bit of an under prediction because it's smaller than the 50.5, but that's really close. And then because we used a cell reference, I can click on the cell, hover over the bottom right-hand corner until I get a plus sign, and then drag it across, and it's going to fill in the whole prediction row. So we see with 8.8 inches of rain, we also had an under prediction. Our equation predicted about 43 inches when there were in reality 46 inches. But then for 13.4 inches of rain, we had an over prediction. Our equation said that we would get 62.9 and we only got 58.8. So you can see for each one, the equation's a little bit off, but that's to be expected. It's not perfect. In the real world, regression models are almost never perfect, but they're pretty close. So the last part is we want to see what would the wheat yield per acre be if we had 14 inches of rain. So I'm going to add a new column to my chart for 14 inches, and then I'm just going to drag this equation over one more spot, and it'll automatically plug 14 into the equation for me to see if there are 14 inches of rain. The equation predicts that we would have 65.57 bushels of wheat per acre.